In science, the most important discoveries rarely announce themselves. They do not arrive with certainty, they arrive with discomfort. An object known as 3I Atlas recently passed Mars. Quietly, without spectacle. At first glance, it seemed unremarkable. A small body, a fast trajectory, another visitor from interstellar space, and yet something about it refuses to settle, because when astronomers examined the earliest images, they noticed not what was there, but what was missing. No obvious tail, no surrounding cloud of gas, no clear signs of activity. For an object approaching the inner solar system, this absence is not trivial. It challenges our expectations. Interstellar objects are rare, but they are not unfamiliar anymore. We have seen two before. The first, Oumuamua, surprised us by accelerating without visible outgassing. The second, Borisov, behaved much more like a traditional comet. 3I Atlas appears to belong to neither category cleanly. That alone is enough to deserve attention. Science does not advance by ignoring anomalies. It advances by studying them carefully. When an observation does not fit our models, we have two choices. We can force the data to fit our expectations, or we can update our understanding of reality. The history of science is clear about which path leads forward. What makes 3I Atlas especially interesting is not speculation, but restraint. There are no dramatic claims here, no declarations of extraterrestrial technology, no conclusions drawn prematurely, only questions. Where did it come from? Why does it behave the way it does? And what does it tell us about the environments beyond our solar system? These questions matter, because interstellar objects are not just rocks in space. They are fragments of other planetary systems. They are physical samples of regions we may never visit. And occasionally, they force us to confront the limits of our assumptions. The passage of 3I Atlas past Mars offered a rare observational opportunity. Mars acts as a natural reference point, a place where gravitational effects, illumination, and motion can be measured with greater precision. What we saw raised new questions, not because the object did something extraordinary, but because it did not do what we expected. And in science, that is often where the real story begins. Today, I want to walk you through what we know, what we do not yet know, and why maintaining an open, disciplined mind is essential. Because the universe does not reward certainty, it rewards curiosity. Narration script. 3I Atlas was detected by the Atlas Survey, a system designed to identify near-Earth objects and transient phenomena. Its designation tells us immediately that it is interstellar. It did not originate from our solar system. It is not gravitationally bound to the sun. This fact alone makes it valuable. Interstellar objects offer insight into the diversity of planetary systems. They carry information about processes that shaped worlds far beyond our reach. But value does not imply mystery. Most interstellar objects, in principle, should follow understandable physical rules. They should respond to solar heating. They should exhibit predictable changes in brightness. They should behave consistently with known materials. 3I Atlas complicates this picture. As it approached Mars, astronomers monitored its brightness and morphology. They expected to see signs of sublimation, gas escaping from the surface due to heating. This is standard cometary behavior, but the data did not clearly support this expectation. There was no prominent coma, no well-defined tail. This does not mean outgassing was absent. It may simply have been below detection thresholds. But the ambiguity matters, because ambiguity forces us to consider alternatives. One possibility is that 3I Atlas is unusually compact or depleted of volatiles. Another is that it is composed of materials that sublimate differently than water ice. Nitrogen ice has been proposed in past cases. Hydrogen outgassing has also been discussed. Each explanation is plausible. None are confirmed. What matters is that our standard assumptions are insufficient, and this is not a failure of science. It is science working as intended. The danger arises when we prematurely close the discussion. When we label something understood, simply because it makes us comfortable. The passage near Mars allowed for precise tracking of its trajectory. So far, no dramatic non-gravitational acceleration has been confirmed. That is important. It means we are not facing the same situation as Oumuamua, but the absence of one anomaly does not eliminate others. The object's reflectivity, shape, and surface composition remain uncertain. These parameters matter because they influence how an object interacts with radiation and gravity. In astrophysics, small forces accumulate over long distances. A subtle effect can produce significant outcomes. This is why careful measurement matters more than speculation. 3I Atlas also invites a broader discussion about how we approach the unknown. There is a tendency in science to favor familiar explanations. This is understandable. Familiar explanations have worked well in the past. But history reminds us that progress often comes from resisting that instinct. When pulsars were first discovered, they were jokingly labeled little green men, not because scientists believed that explanation, but because they acknowledged their uncertainty. Eventually, a natural explanation emerged. The key was openness, not denial. With interstellar objects, the stakes are similar. Most will be natural, perhaps all of them. But the cost of refusing to ask broader questions is high. If even one object exhibits characteristics inconsistent with natural formation, the implications would be profound. This does not mean assuming such a conclusion. It means allowing the data to speak. In the case of 3I Atlas, the data is still incomplete. Future observations may reveal faint activity. Spectroscopy may clarify its composition, and when that happens, the mystery may dissolve. That outcome would still be valuable, because understanding the diversity of natural objects is itself a scientific achievement. What matters is maintaining intellectual honesty. Rejecting extraordinary claims without evidence is rational. Rejecting questions without examination is not. The universe is not required to conform to our expectations, and it has a long history of surprising us. Narration script. Science is not a collection of answers. It is a method for asking better questions. 3I Atlas reminds us of that. It did not arrive with certainty. It did not announce its nature. It simply passed through, leaving behind measurements, images, and unanswered questions. This is how discovery often begins, not with revelation, but with restraint. As observers, our responsibility is not to sensationalize, but to remain curious, to resist the urge to dismiss what we do not yet understand. Whether 3I Atlas proves to be a rare natural object or something entirely expected in hindsight, it has already served an important role. It has reminded us that our knowledge is incomplete, that humility is a strength, not a weakness, and that the universe is still capable of challenging us. When future generations look back, they may see this moment as insignificant, or they may see it as the beginning of a deeper understanding of our cosmic environment. Either way, the correct response is the same. Observe carefully, think openly, and let evidence guide us. The universe does not whisper secrets to those who are certain. It speaks to those who are willing to listen.